Hello, friends, welcome to my channel Shamir Eco with new interesting video. Difference between voltage and current. Voltage and current are two fundamental concepts in electronics that are related to the flow of electrons. Voltage, also known as electric potential difference, is a measure of the potential energy difference between 2 points in a circuit. It is the force that drives electrons to move through a conductor. The voltage is created by a source, such as a battery or power supply, and is measured in volts, V. Current, on the other hand, is a measure of the rate of flow of electric charge through a circuit. It is the movement of electrons from a region of higher potential energy to a region of lower potential energy. Current is measured in amperes, A, and it is the flow of electrons that produces a current. The flow of electrons in a circuit is affected by the voltage and the resistance of the circuit. A higher voltage will cause more electrons to flow through a circuit, while a lower voltage will result in less flow. Resistance is a property of the circuit that affects the flow of electrons, and it is measured in ohms. Ohm's law describes the relationship between voltage, current, and resistance in a circuit. According to Ohm's law, the current flowing through a circuit is directly proportional to the voltage and inversely proportional to the resistance. In summary, voltage is the potential energy difference that drives the flow of electrons, while current is the actual flow of electrons through a circuit. Voltage and current are related to each other through the circuit resistance, and their relationship is described by Ohm's law. How electrons or voltage flow. Electrons are negatively charged subatomic particles that are found in the outer shells of atoms. In some materials, such as metals, the outermost electrons are loosely held and are free to move around the material. When a voltage is applied to the material, the free electrons will move in response to the electric field created by the voltage. This movement of electrons is known as an electric current. The flow of electrons in a conductor is always from the negative terminal of the voltage source to the positive terminal, opposite to the direction of conventional current. This is because electrons are negatively charged and are attracted to the positive terminal of the voltage source. The flow of electrons is influenced by the resistance of the conductor, which is determined by the material and dimensions of the conductor, as well as the temperature. The resistance of the conductor can be reduced by increasing its cross-sectional area or decreasing its length, or by using a material with lower resistivity. In summary, the application of a voltage creates an electric field that causes free electrons in a conductor to move, resulting in the flow of electrons or electric current. What is the difference between AC and DC? AC, alternating current, and DC, direct current, are two types of electrical current that differ in the way that the electric charge flows through a circuit. AC is a type of current that changes direction periodically, meaning it flows in one direction for a certain amount of time, then changes direction and flows in the opposite direction for an equal amount of time. AC is used to power most household and commercial electrical devices, such as refrigerators, air conditioners, and computers. DC, on the other hand, always flows in the same direction. It is commonly used to power small devices like mobile phones and batteries, as well as in certain industrial applications such as electroplating and welding. One of the key differences between AC and DC is that AC can be easily transformed into different voltage levels using transformers, while DC cannot be transformed in the same way. Another difference is that AC is generally more efficient when transmitting power over long distances, while DC is better suited for short distances. Overall, the choice between AC and DC depends on the specific application and the characteristics of the device being powered. How power is generated. Power can be generated in several ways, including fossil fuels. Fossil fuels, such as coal, oil, and natural gas, are burned to generate steam, which drives turbines that generate electricity. Nuclear energy. Nuclear power plants use nuclear reactions to generate heat, which is then used to produce steam and generate electricity. Hydroelectric power. Hydroelectric power plants harness the energy of falling water to generate electricity. This is done by using dams to create a reservoir of water, which is then released through turbines. Solar power. Solar power uses photovoltaic (PV) cells to convert sunlight into electricity. The PV cells are made of semiconductor materials that absorb photons from sunlight, which in turn creates a flow of electrons that generates electricity. Wind power. Wind turbines use the power of wind to turn blades, which drive a generator to produce electricity. Geothermal power. Geothermal power plants use heat from the Earth's interior to produce steam, which is used to generate electricity. Each of these methods has its advantages and disadvantages, and the choice of which method to use often depends on factors such as cost, availability, and environmental considerations. Thanks for watching. Please like and subscribe.